Developers are racing to build free AI agents that browse the web, assuming their local GPUs can handle it. The reality is a fundamental architectural mismatch between human browsing habits and how large language models require massive context windows for autonomous decision-making. Running these agents locally creates an impossible bottleneck between memory constraints and security risks, forcing engineers to choose between expensive cloud APIs or unstable deployments that fail under real-world load. Today, we connect this trend of three free tools to the engineering trade-offs behind why local AI browsing is a trap for production systems. The first step in understanding this failure mode is realizing how human web usage differs from what current agents are engineered to do. Longitudinal data tracking thousands of households over 4 years, published by major research institutions and spanning from 2013 through 2016, reveals a critical disconnect. The study shows that actual human navigation is characterized by short linear paths with rapid session termination. We click, find what we need, and leave. However, current browsing agents are designed to handle deep, complex exploration chains requiring massive context windows. They assume every task requires the AI to think through multiple layers of uncertainty and long-term planning. This mismatch forces local GPUs to process excessive context for trivial tasks. When an engineer tries to replicate human behavior on a consumer machine, they often program the agent to overprocess simple queries as if they were complex research projects. The GPU must maintain a massive state window to remember every page visited during a short session that should have taken seconds. This creates a computational bottleneck where resources are drained without adding value. You end up with an agent that is slow, consumes all available memory, and still fails to complete the task efficiently because it is trying to solve for complexity that does not exist in reality. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Beyond performance, there is a severe security surface area issue that local hardware cannot isolate effectively. A white box analysis of popular open-source browsing tools released in May 2025 demonstrates that autonomous agents face vulnerabilities including prompt injections and credential theft via untrusted web content. When an agent interacts with malicious sites or compromised pages, it can be hijacked to execute commands on the host system. Unlike cloud environments where sandboxing is managed at the infrastructure level by providers like Google Cloud or AWS, local deployments on consumer GPUs lack this isolation layer. The result of running these agents locally is that your developer machine becomes an attack surface for data exfiltration and domain validation bypasses. You cannot enforce a defense in-depth strategy against hijacked agents using standard hardware alone. The hidden cost here is not just compute, it is the inability to prevent a compromised agent from stealing credentials or installing malware because the boundary between the browser process and your operating system is too porous on a local setup. This turns the convenience of free, local AI into a significant liability for any team handling sensitive data. The final piece of this puzzle involves the efficiency gap regarding energy and context overhead in modern search paradigms. Current AI search operates on logic distinct from traditional SEO, exhibiting systematic biases toward earned media rather than brand-owned content. This shift requires models to process vast amounts of unstructured data with high freshness requirements that change constantly. Research indicates that maintaining these large context windows locally is unsustainable compared to cloud inference because the energy overhead per token becomes prohibitive when running continuously on a single device. The free local tool model ignores the massive carbon and compute costs required to keep a low-latency, secure agent running on-device versus offloading it to specialized infrastructure designed for this specific load pattern. While you might save money on API calls initially, the engineering time lost debugging unstable agents that fail to replicate simple human browsing patterns due to hardware constraints is far more expensive. The hidden cost of local browsing includes the electricity consumed by a GPU working at full capacity just to maintain context windows that cloud providers have already optimized for scale and safety. If you are building AI agents or designing data pipelines that rely on web browsing capabilities, your current mental model of local first is flawed. You cannot simply swap a cloud API call for a local LLM instance without accounting for the latency and memory requirements needed to maintain context during autonomous navigation. These constraints will crash standard developer setups when faced with real-world traffic or complex queries. The trend toward three tools at zero cost ignores this infrastructure reality, leading to deployments that look good in a demo but fail under pressure. For production-grade browsing agents, engineers must accept that context is expensive and security requires isolation. Local GPUs struggle with the token volume required to understand complex web pages without hallucinating or stalling. The trade-off for running these systems locally involves accepting high failure rates and significant security exposure. Cloud APIs, or hybrid architectures, remain the only viable engineering choice for production because they provide the necessary infrastructure-level sandboxing and compute scaling that local hardware cannot match. The path forward requires acknowledging that human web navigation is defined by short, linear paths, while forcing an LLM to treat every session as a deep exploration chain creates a computational bottleneck that local GPUs simply cannot resolve without massive resource expenditure. The security of your data depends on infrastructure-level isolation, which consumer hardware lacks when running untrusted web content locally. Engineers must weigh the apparent savings against the hidden costs of energy, stability, and risk management in their architectural decisions for AI agents. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.